7, 6, 5, 4, 3, 2, 1. Liftoff.
Click the button, see if you can launch button.
Beginning pitch over. Stage 1 propulsion nominal.
IoT for you and me is on its way to space. Electron has lifted off from the pad at Launch Complex 1 and has commenced its 9-minute journey to orbit. The vehicle has cleared the pad, so next up is max Q, or maximum aerodynamic pressure. This is the moment in flight when Electron experiences peak structural load. Let's listen in for that call out from Mission Control.
Cleared max Q.
And that's the call we're looking for. Electron has successfully cleared max Q. We're now at 15 kilometers in altitude and traveling at over 2,200 kilometers an hour. Up next is a particularly busy time in flight. Electron will go through main engine cutoff, or MECO, followed by stage separation and then second stage ignition. Having depleted all the propellant in the first stage, we don't need to carry what is essentially a giant empty fuel tank the rest of the way to orbit. So we jettison the first stage and continue the rest of the mission with just the stage 2. Let's listen in for those calls.
Stage 1 propulsion holding nominal. Stand by for MECO in approximately 30 seconds. "15 seconds till staging."
Entering burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
There we have it, successful MECO, stage separation and second stage ignition confirmed. Electron's second stage is now continuing the mission to orbit with those 5 Kinéis satellites attached to the kick stage. Very soon we can dispense of the fairing that has been protecting those satellites from the intense conditions of launch. The 2 halves of the fairing will split and fall away, exposing the satellite to space in preparation for deployment. Those are the magic words. Electron's fairing has been jettisoned. We are now at 3 minutes into flight with less than 6 minutes remaining in this second stage burn.
Hey Phoebe, discharge holding nominal.
With Electron's fairings gone, the payloads are now exposed to the vacuum of space. But we're doing things a little differently with Neutron. Neutron's captive fairing will stay attached to stage 1, and our second stage will be deployed from within. The fairing halves are large and complex composite structures, so we prefer to keep hold of them for rapid reuse of stage 1.
Stage 2 propulsion.
Some stunning views of Earth there from space as we head out over the South Pacific Ocean. T plus 4 minutes into flight, and Electron is soaring at around 11,000 kilometers per hour, passing through 180 kilometers in altitude.
So far, Electron has progressed through a successful liftoff, stage separation, second stage ignition, and fairing separation. These are all pretty standard phases in flight for all launch vehicles, but the next milestone is one that's unique to Rocket Lab. We call it battery hot swap. The batteries powering the electric motors driving the propeller pumps on the engine deplete over time, and when they're drained, we eject them and swap to a fresh set for the rest of the journey to orbit. Watch closely and you might just see those batteries slip out of sight once jettisoned.
Throttling down.
Battery jettison confirmed.
Bye-bye batteries. That is a successful hot swap. We are now around 6 minutes into flight at an altitude of about 206 kilometers. We have sailed through most of the key milestones for this launch, with just a few more to come, including SECO, or second engine cutoff. At that point, the Rutherford engine will throttle down, eventually coming to a stop in preparation for kick stage separation. That moment will mark the end of the first mission phase, and it's coming up at 9 minutes into flight.
AFTS has saved.
So what you're looking at on your screen is our vacuum-optimized Rutherford engine. It might look simple, but there's a lot of systems keeping everything running smoothly. Each engine, sea level and vacuum, has a dedicated engine controller which performs local, closed-loop control computations for that engine. That involves sensor sampling, processing, and also position control of engine valves and actuators. This includes the thrust vector controllers, or TVCs, which gimbal the engine to give us direction. However, each of these engine controllers are themselves centrally commanded by the flight computer, which performs the overall guidance, navigation, and control for the entire vehicle.
Entered burnout detect mode.
You might remember earlier in the show we mentioned that Rutherford would begin to throttle down for shutdown. Well, we're now fast approaching that point. Soon you'll hear an operator call out entered burnout detect mode, and you'll know that SECO is close.